Okay, rationalizing sets with binomial denominators. The previous video we looked at how to rationalize a set with a monomial denominator. We learned how to rationalize sets with monomial denominators. Now we are going to look at sets with binomial denominators. And the term binomial denominator in mathematics refers to a denominator in a fraction that contains two terms by, as in two, by. Great. So if we have a denominator in the form a plus b or a minus b, that is a binomial denominator. When an expression contains a said binomial denominator, then it needs to be rationalized by multiplying through by the conjugate of the denominator. So we have another term to think about, conjugate of the denominator. What is the conjugate of a denominator then? Okay, the conjugate means a pair of binomial expressions that have the same terms but opposite signs between them. They have the same terms but an opposite signs between them. The conjugate of a binomial involving set is obtained by changing the sign between the two terms. And so if we want to find the conjugate of a term, we rewrite the same term but then change the sign between the term. The reason for doing that is that we want to obtain the difference of two squares, which effectively eliminates the said denominator and thus rationalize them. We want to rationalize the set. So for binomial terms, you have to take the conjugate. When you take the conjugate and multiply through, then we have difference of two squares, and so it eliminates the said denominator we have. Like always, a good example helps. So let's see. If we have an expression 3 plus root 2, how do we go about it? To understand the terms conjugate, let's look at some few examples. First, we have 3 plus root 2. If we have this term and then we want to take its conjugate, like we said, the conjugates are the terms that have the same numbers but then an opposite sign. And so with this example, the conjugate of 3 plus root 2 will be 3 minus root 2. That is the conjugate of this. The same expression, different signs or opposite signs. How about this one? Root 3 minus root 2. Okay, the conjugate will be root 3 plus root 2. So the same expressions, opposite signs. How about this one? 7 root 3 minus 4 root 2. Can we guess? That would be 7 root 3 plus 4 root 2. The same expression, different or opposite signs. So in a nutshell, when you rationalize the binomial set by multiplying through by the conjugate set of the denominator and simplify them, we get an expression that is rationalized, and that is why we take the conjugate set of them. Alright, like always, let's take some examples for this as well. How would you rationalize this expression 4 over root 7 minus root 3? Mind you, now we find that there's a binomial term. If it were to be a monomial term, we just take the said expression here. Let's say if it were to be 4 over root 7, then we just go ahead and multiply through by root 7. But this case, it is a binomial term. And so we first take the conjugate of root 7 minus root 3. And what is the conjugate? That is root 7 plus root 2, like we learned earlier. Great. And so we multiply the numerator and the denominator by root 7 plus root 3 like this. Okay, so this is how it will look like. We took this expression and found its conjugate to be this, and we multiply the conjugate by the numerator and then also the denominator. And so we have 4 times 7 root 3, then root 7 minus root 3 times root 7 plus root 3. And this expression gives us 4 times this and then 4 times this as well. Then later will be this times this, then root 7 times 3. Then we'll take this one to and multiply it by both root 7 and also root 3. When we do that, this is what happens. So we have 4 root 7 here because 4 times 7 root 7 is 4 root 7. We also have 4 root 3 here. That came from multiplication of 4 times root 3, which gives 4 root 3. So this is covered. How about these ones? We have root 7 multiplying everything here, then root 3 multiplying everything here. So root 7 times root 7 is root 7 squared. Now root 7 times 3 is root of 21. 7 3 is 21 under the square root. Now we take this one, negative root 3 times root 7 is negative 21, and then negative root 3 times 3 root 3 gives negative root 3 squared. And that is why we have this expression here. Now clearly you can see that we can simplify things further. Root 7 squared becomes 7 and then root 3 squared becomes 3. Nothing has changed much. We just simplify these two expressions. You can also see that we have square root of 21, positive 21 here, then square root of negative 21. And so these two expressions too can go away. They cancel each other. Negative and positive of the same number become 0. So these two cancel out. And so we can further reduce our expression to 4 root 7 plus 4 root 3 all over 7 minus 3 gives 4 all over 4. Right. Now this expression basically means 4 over 7, 4 root 7 over 4 plus 4 root 3 over 4. But then we can factor the 4 out since it is common to both of these two expressions. And so we factor the 4 out. We have 4 into bracket root 7 plus root 3. When you expand this, you are going to get the same thing here. Now from here we can see that 4 can cancel 4 both in the numerator and the denominator. So that is what we are going to do. 4 cancels 4 here, and thus our final expression becomes root 7 plus root 3. This is how we go about simplifying or rationalizing a binomial set expression. This is how we go about it. Okay, can you take this example? Express 8 minus 2 root 6 all over 2 root 3 minus 3 root 2 in the form m root 3 plus n root 2, where m and n are rational numbers. This is basically asking that we rationalize this expression. Alright, now this is our expression, and the first thing to do is to find the conjugate of our denominator here. 2 root 3 minus 3 root 2. What will be the conjugate of that? Quick. What's your suggestion or answer to that? That is this. It will be 2 root 3 plus 3 root 2. And so we are going to multiply both the numerator and the denominator by this expression. Okay. When we do that, this is what we get. This is what we get. We have 8 minus 2 root 6 times 2 root 3 plus 3 root 2. Then we have 2 root 3 minus 3 root 2 times 2 root 3 plus 3 root 2. And so here 8 will multiply each of these expressions. 2 root 6 would multiply each of these expressions. The same thing happens here. When you take this, it will multiply both this and that. When we take this as well, it will multiply this and that. This has been thoroughly explained under the topic multiplication of sets. So if you don't know how to go about it, I would recommend you watch that video. Okay, Now from here, we just have to simplify. And so we have 8 times, we have 8 times 2 root 3. This times this is what we are having here. We also have 8 times 3 root 2, and this is what we have here. Then we take this expression and multiply by this. So we have 2 root 6 times 2 root 3. This is what we have here. We are using the bracket to make it simple for us to visualize. And so this time this is what we are having. Then again, this times this is what we have here. We have 2 root 6 times 3 root 2. This and this. The same thing happens with the denominators. We have 2 root 3 times 2 root 3. And so we have 2 root 3 squared. Then we have 2 root 3 times 3 root 2. And that is the expression we have here. Now we come back to this. Negative 3 root 2 times 2 root 3. This is what we are having. Then negative 3 root 2 times 3 root 2. We have 3 root 2 squared. Everything from here on isn't said per se. It is just simplification. Now 8 times 2 root 3 will give us 16 root 2. Root 3 plus 8 3 is 24 root 2. 2 is 4. And then root 6 and then root 3 gives root 18. Now this and this gives 6 root 12. This gives us 4 times 3 because we have 2 squared times 3 squared, and then 3 squared is basically 3, then 2 squared is 4, and that is why we have this expression. Then again, 2 root 3 times 3 root 2 is 6 root 6. 2 times 3 is 6. 3 times 2 is also 6 from this expression. Again, if you don't understand this, I suggest you watch the multiplication of sets. We have this as well. We have 3 root 2 times 2 root 3, which gives 6 root 6. Then finally, we have this expression. 3 root 2 squared gives us 9 times 2. Okay. We can tell this and that can go away. They are the same expression. Alright. Let's see. Now this is the same expression we have where we arrived at this place where these two expressions cancelled out. We still have to go further. But if you look at the said here and the said here, they can be simplified. If you take 18 for instance, it is 9 times 2. And 9 times 2 is 3 squared times 2. 3 is 9, so we can represent 9 by 3 squared, which eventually gives us 3 root 2 because this cancels itself. Now, the same thing can be said of 12. So we are going to represent 18 by its set form. So this is everything we have by simplifying things further. We have 4 times 3 is 12, and then 9 times 2 is 18. And then we simplified everything through the 16 root 3 plus 24 root 2 minus 4 times 2 times 3 root 2. This is representing 18 as 9 times 2, and then rewriting the 9 as 3 root 2. The same thing is happening here with 12. You can see that 12 is 4 times 3, and then 4 is 2 to the power 2 times 3, like this. And then we have 2 root 3 for it. Great. And so from this is the next step. After simplifying the terms we have here, we have 60 root 3 plus 24 root 2 minus 4 times 3 root 2. This is after simplifying root 18. And this is also after simplifying root 12. Good. Now, a more simplified form, you have 16 root 3 plus 24 root 2 minus 12 root 2 minus 12 root 3 all over negative 6. 12 minus 18 is negative 6. From here, we can see that we have some like terms. We have root 3 here and root 3 here. So these two can be added together, then these two can also be added together. 16 minus 12 gives us 4 root 3. Then 24 root 2 minus 12 root 2 gives us 12 root 2 all over negative 6. From here we are done. We can't simplify any further. Just that when you look at this expression, it's simply 4 root 3 over negative 6 plus 12 root 2 over negative 6. That is this. When we split this expression, this is what we are having. Okay, now 4 root 3 over negative 6, you can see some terms can cancel out. 2 goes into 4 and 6, and then 6 goes into 12 as well. When we simplify it, instead of 4 root 3, we now have 2 root 3 over 3. But this time it's negative because the denominator is negative. So we have negative 2 root 3 over 3. Then this one too will be negative 2 root 2. And so we see that the expression told us to express our set as m root 3 and then n root 2. And now we see that negative 2 over 3 becomes our m, and then negative 2 becomes our n, because this is just like the expression we were given. We can see m is equal to negative 2 over 3 and then n is negative 2. As it turns out, this is a past WASI question, and so if we're able to go through, or if you're able to follow, it means that if you had that question, you would have aced it. And so I entreat you to go through the process again, watch the video carefully if the need be, and then it would help you to be able to solve more complex questions. And so this is how you rationalize a set. First, we did the rationalization for a monomial term in the previous video, and in this video we've covered a rationalization of a binomial set. Great. Make sure you like the video, you subscribe if you haven't, you comment if the need be, and then share the video to others who may benefit from it. See you next time.